All right, we're covering 5.3, monomial factors of polynomials. So basically, what we're doing is dividing polynomials. All right, so let's recall a general rule first. Let's see. If A, B, and C are real numbers, and C not equal to 0, then we know that we can write A plus B over C is the same as A over C plus B over C. So this is a general rule dealing with numbers. All right. So let's look at a brief example of that now with polynomials. So if we had 5m plus 35 over 5, and we want to divide this, well, we're going to use these same rules. So it comes out to 5m over 5 plus 35 over 5, which can be simplified. If we cancel our 5's here, we're left with an m, and then 5 goes into 35 7 times. All right, so we're going to basically be using this rule for the first half of this lesson, and then for the second half of the lesson, we'll be doing factoring. All right, so let's look at a couple other examples. 26uv minus 39v divided by 13v. We're going to do the same thing here. We're going to split it up over the denominator. 13v minus 39v over 13v. And then we'll just start canceling stuff out. The v's cancel with each other in this first term. 13 goes into 26 2 times, so we're left with 2u there. In the second term, the v's cancel again, and 13 goes into 39 3 times, so we have a final answer of 2u minus 3. So very similar to the first example, just a couple of more variables in it. And let's do one that's a little more involved. We got 3x to the 4th minus 9x cubed y plus 6x squared y squared, all divided by negative 3x. So we're still going to split it up over the denominator. What we have to be careful here is the denominator has a negative term in it. So we've got 3x to the 4th over negative 3x squared minus 9x cubed y over negative 3x squared plus 6x squared y squared over a negative 3x squared. Now we cancel our like terms. We got an x squared in the denominator and x to the 4th in the numerator, so we're left with just an x squared at the top. Positive 3 divided by negative 3 leaves a negative 1. So our first term comes out to negative x squared. Here, just so we don't lose the negative, I'm going to add the opposite here, just so we keep track of it, how it's going. So the x's, I got an x squared in the denominator and x cubed in the numerator. So we're left with an x and a y. And then negative 9 divided by negative 3 is a positive 3. So we've got negative x squared plus 3xy. And then our last term, the x's cancel completely. And then 6 divided by negative 3 is a negative 2. So we carry our y squared. So it's a little tedious, but not too bad. Be careful of negatives in the denominator on how we do that. Otherwise, follow this same rule and just split it up over the denominator. Now what this leads us into is factoring. So we're just going to go straight into an example, and then we'll explain what it looks like. The idea behind factoring goes back to a combination of division with this rule and a greatest common factor. So if all I said factor 5x squared plus 10x, what it's going to come down to is this. We're looking for the greatest common factor between these terms. So let's start with the variables first. And what we'll say is, what can we pull out of these variables? Well, we can pull out, we've got an x squared here and an x. So the biggest thing we can pull out is an x. And then numerical, the biggest thing we can pull out is obviously a 5. So we can pull out a 5x of this term. Now we need to figure out what goes in these blanks. Well, what do we multiply 5x by to get 5x squared? Well, that's just simply x. And what do we multiply 5x by to get 10x? And that's simply 2. So factoring 5x squared plus 10x comes out to 5x times x plus 2. And you can check your answer by multiplying back into these terms to make sure you get back to the original. So when we say factor, really all we're doing is pulling out the greatest common factor of each term and then figuring out what we need to multiply by to get back to our original equation. Alright, let's do a couple other examples and then we'll wrap it up for 5.3. Let's say factor 4x to the 5th minus 6x cubed plus a 14x. So just like we did in the previous example, we're looking for the greatest common factor of all these, and I'm going to start with the variable. Well, the largest x I can pull out is just x. Alright? Then we'll look at our numbers. Well, 4, 6, and 14 are all even, so we know we can pull a 2 out, and that's the largest number we can pull out. So we can pull out a 2x. Now we need to figure out what do we multiply by to get back to the original. So 2x times what gives 4x to the 5th? Well, we know 2 times 2 gives us 4. And we know that if we put an x to the 4th here, adding our exponents with the same base, will get us back to x to the 5th. So the first term becomes 2x to the 4th. This term we need to figure, what do we multiply 2x by to get 6x cubed? Well, we know 2 times 3 gives us 6. We've got 1x here, which means we need 2 more to get back to the original. And then lastly, what do we multiply 2x by to get 14x? Well, we know 2 times 7 gives us 14, and we already have the x in place. So factored form of 4x to the 5th minus 6x cubed plus 14x, we pull out a 2x and it turns into this polynomial here. So it's not too crazy. Let's do one more example and that will wrap up this lesson. Let's see, factor 8a squared bc squared minus 12a b squared c squared. So again, we're looking for greatest common denominators. Let's start with our variables first. We'll take them one at a time. The largest thing I can pull out as far as a concerned is just an a. The largest thing I can pull out as far as b is concerned is just a b. And then both terms have a c squared, so I can pull a c squared out. There's a blank here and a blank here. Now let's look at our numbers. The largest number that goes into both of these, well, we know that's 4. So the final step is just multiplying to get back to the original. So what do I multiply 4abc squared by to get back to the original? Well, we know 4 times 2 is 8. We know we're missing 1a. The b is already in place, and the c squared is already in place. So the first term just becomes 2a. For this blank, we need to look and see what do we multiply 4abc squared by to get 12ab squared c squared. Well, we know 4 times 3 is 12. The a is in place, the b we're missing 1, and the c squared is in place. So the factored form here, 4ab c squared times 2a minus 3b. So that's pretty much 5.3, division of polynomials and factoring polynomials, which is basically the same function, just doing it 2 different ways.